Hello, viewers. In today's session, we are going to discuss another important problem from differentiation under the sign of integration. Right. So here we are going to evaluate this integral using the concept of differentiation under the sign of integration. Right. So let us see how we can solve this problem, and we have already discussed a lot of problems related to this topic, that is differentiation under the sign of integration, right? So let us first take this integral as I, right? And here we have the integral, that is 0 to infinity e raised to minus ax minus e raised to minus bx divided by x, right? So what we'll do here, will differentiate both sides with respect to a, right? Now see, here we have a and b, so we have here two constants a and b, and the concept behind differentiating an integral under the sign of integration is that we treat this a or this b as a variable, right? So here we'll prefer a and will differentiate both sides with respect to a. We can also select this constant, that is b, as a variable, right? So we can also differentiate both sides with respect to b also, but here we'll differentiate both sides with respect to a. So here we have now a di over dA, and here we have to take the partial derivative of this integrand with respect to a, and we'll consider all other variables or the terms as a constant, right? So we have here del over del a, and here we have 0 to infinity e raised to minus ax minus e raised to minus bx over x and dx. So now we can take this operator, that is the derivative operator inside the integral sign, right? So we have 0 to infinity, and we have del over del a e raised to minus ax minus e raised to minus bx over x, and here we have a dx. So here we have di over a dA. So now let us write here 0 to infinity del over del a, and let us write our integrand like this: e raised to minus ax over x minus e raised to minus bx over x, and here we have dx, right? So distributing this x over this term and this term, right? Now we can see that here this expression is a function of a, and here we do not have a, right? So this term may be considered as a constant, right? Because we have to take the partial derivative of this term, so we can treat this entire term as a constant because the partial derivative is to be calculated, right? And here we have e raised to minus ax, so we can now write 0 to infinity, and here we have 1 over x and del over del a of e raised to minus ax, and the partial derivative of this term is 0, and here we have a dx. So now we have a 0 to infinity 1 over x, and the derivative of e raised to minus ax is e raised to minus ax, and then by chain rule we have to differentiate minus ax with respect to a, that is a minus x, right? So here x and x get cancelled, so now we have di over dA is equal to negative. We can take this negative outside the integral sign, so we have 0 to infinity and e raised to minus ax, and here we have a dx, right? So now we'll solve this integral by the usual method, and then we'll have a differential equation. So now here we have negative sign, and the integral of e raised to minus ax is e raised to minus ax over minus a, and here the limits of integration are from 0 to infinity. So now here this negative and this negative get cancelled. We can take a 1 over a, and here we have e raised to minus ax and 0 to infinity, right? So now here we can see that when x tends to infinity, that is the upper limit, when x tends to infinity, then e raised to minus ax, it tends to 0, right? Because here when x tends to infinity, then we have e raised to minus infinity, and e raised to minus infinity, it tends to 0, right? So now here we have 0, and then we take x is equal to 0. So here we have e raised to minus a times 0, that is 0, and e raised to 0 is 1. So we have 1 over a times e raised to, here we have simply 0 minus 1, that is minus 1 over a, right? So now we have di over dA is equal to minus 1 over a, and this is a first order and first degree differential equation. So now this is a variable separable form of differential equation. So separating the variables, we have di, and here we have minus 1 over a and dA. So separating the variables. Now integrating both sides, and here we have c as the constant of integration. So here we have I, and here we have minus integral dA over a plus c, that is minus a logarithm of a plus c. So the integral dA over a is natural log of a. So here we have I is equal to minus natural log of a plus c, right? So when we have assumed this integral as I, then I is treated as a function of a, right? Because we are differentiating both sides with respect to a. So we can also take I as I of a, but here we'll prefer this notation, right? So I is equal to negative of natural log of a plus c. So now our aim is to find out the value of c. So now this constant of integration c can easily be obtained by applying this condition, that is a is equal to b in this integral, right? So when we take a is equal to b in this integral, then the value of I is equal to 0 to infinity e raised to minus ax minus e raised to minus ax over x dx, and we can see that these two terms get cancelled. So this is simply equal to a 0. So now when a is equal to b, then the value of I is equal to 0. So let us apply this condition to this equation. So I is equal to 0. Here we have a negative of natural log of b, because we are taking a is equal to b, then I is equal to 0, and here we have c, right? So taking this term to this side, the value of c is equal to positive natural log of b, right? So the constant of integration c has this value natural log of b when we take a is equal to b. So substituting this value in this equation, we have now the value of I as negative of natural log of a plus natural log of b, and we can now write here a natural log of b minus natural log of a, and using the laws of exponents, we can easily write this expression as natural log of b over a, right? Because we know that natural log of m over n is given by natural log of m minus natural log of n, right? So the value of this integral I is given by this expression, that is natural log of b over a. So viewers, this is how by the application of differentiation under the sign of integration, we can easily find out the values of integrals of these kinds. Right now, here we can take one simple case here by assigning particular values to a and b. Now see, if we take a is equal to say 2 and say b is equal to 3, right? Then the integral I, it takes the form 0 to infinity e raised to minus 2x minus e raised to minus 3x over x dx, right? So the value of this integral can easily be written with the help of this expression. So here we have natural log of b over a. B is 3 and a is 2. So we have natural log of 3 over 2. So the value of this integral is equal to natural log of 3 over 2. Similarly, we can find out the values of other integrals also by assigning different valid values to a and b.